Introduction. Newton's law of cooling. Ordinary differential equation. A differential equation involving one or more functions of one independent variable and derivatives. Newton's law of cooling. The rate of cooling of an object is proportional to the difference between its temperature and the ambient temperature. The linear first order equation of Newton's law. T prime T equals to K T minus T0. The T denotes as the temperature of an object. T0 denotes as the ambient temperature. Problem statement. A murder case. The time of death of a murdered person can be determined with the help of modeling through a differential equations. Police personnel discover the body of a dead person presumably murdered, and the problem is to estimate the time of death. The body is located in a room that is kept at a constant 70 degrees Fahrenheit. For some time after the death, the body will radiate heat into the cooler room, causing the body's temperature to decrease, assuming that the victim's temperature was normal 98.6 Fahrenheit at the time of death. The forensic expert will try to estimate this time from the body's current temperature and calculating how long it would have had to lose heat to reach this point.
Next, I'm going to talk about the methodology. According to Newton's law of cooling, explains the rate at which a body changes its temperature when it is exposed through radiation. This is nearly proportional to the difference between the temperature of the object and its environment. However, don't forget to keep in mind that the difference over here is quite small. When we use Newton's law of cooling formula, we can calculate how fast a substance at a particular temperature would cool in any particular environment. Moreover, it also tells us how the rate of cooling of an object depends on the temperature difference between the substance and the surroundings, but also on the cooling constant of the substance. Newton's law of cooling formula is T equal to Ts plus T naught minus Ts exponential power of negative Kt. Differentiate T on K equal negative K bracket T minus Ts. The great physicist Sir Isaac Newton produced a formula that calculates the temperature of a substance as and when it loses heat. Further, what happens over here is that the heat from the objects to its surrounding environment. Moreover, as we have said already, that the rate of the change in temperature is proportional to the difference in temperature between the object and its environment. Similarly, we can use the formula to find out the temperature at any point. As you know, the Kelvin, K is the SI unit of temperature. Don't forget that we use degrees Celsius more often. Therefore, we have formed the formula as T equal to Ts plus T naught minus Ts times with exponential power of negative Kt. The T refers to the temperature of the object at a particular time, and the small t is the time. Ts refers to the temperature of the surrounding environment. T naught is the starting temperature of the object. K refers to a cooling constant explicit to the object. Next, constant K and A can be determined as time of arrival of the police personnel. Second thing is the temperature of the body just after his arrival, and next, the temperature of the body after a certain interval of time.
With the information given, the victim body is located in a room that is kept at a constant temperature, which is 70 degrees Celsius, and by using the Newton law of cooling, we will get a formula which is T equal to 70 plus A times E power Kt. And let's assume that the officer will arrive at 10:40 p.m. and the body temperature was 94.4 degrees at that moment. This means that if the officer considered 10:40 p.m. as T equals to 0, then we will get the following function, which is T equal to 70 plus 24.4 times E power Kt. The officer made another measurement of the body temperature after 90 minutes, that is at 12:10 a.m. The body temperature was dropped to 89 degrees. And by substituting the degree value into the function, and we will get a temperature function which is T equal to 70 plus 24.4 times E to the power of T over 90 ln 19 over 24.4. In order to find when was the last time the body temperature was 98.6 degrees Celsius, which is the estimated time of death, the equation will be written as 98.6 equal to 70 plus 24.4 times e to the power of t over 90 ln 19 over 24.4. And eventually we will get the t value, which is approximately to negative 57.14 minutes. Therefore, this can conclude that the death is occur approximately on 57.14 minutes before the first measurement of 10:40 p.m., that is 9:43 p.m. And the time of death of the victim is on 9:43 p.m. approximately.